class number 20 on loudspeakers for 4440 critical listening. So we've talked about our source component, our sort of routing component, our preamplifier, right? And now we have to talk about our playback component. So as we said, we have a source component, right? Recovers audio signal from the media. Not the press or the media at large, but rather a DVD or a CD. The control component obviously is the way that we then route these different source components and either amplify them if need be, or just simply route them on to the third and final component that we've sort of talked about in the Harley book and in class, and that's the playback component. So this could be both a power amplifier and loudspeaker, or it could be active speakers that have their own power amplifier within them. I show this picture of the to-noise down here at the bottom. They are active speakers. They actually have a power amplifier within them. So power amplifier, much like the preamplifier and the control component, this device matches impedance and amplifies the signal to drive the loudspeaker. The Yamaha NS10s, as you can see here, sort of a studio standard for one reason or another, they are actually passive speakers, so they need an extra amplifier or a power amplifier to actually drive the speakers. There are three main types of speakers. We're really just going to talk about dynamic driver for this sort of short little segment here. There are, of course, ribbon transducers and electrostatic panels. And if you're really interested in those types, Harley goes in great detail in Chapter 6 discussing the advantages and disadvantages of all those types. I think these will probably be less common for sort of, young engineers as yourself, sort of, compiling a system. But probably there's something that further down the road, especially if you, entered a master's program or, even started getting further in your career, these are some things that I think you'd want to take a look at. So basically dynamic drivers work a lot like dynamic microphones in the idea that we have sort of this diaphragm and we're using electrostatic or electromagnetic principle of a voice coil, magnet, and wires and changes in electrical current. Dynamic drivers are also known as point source transducers, and they're the most popular and identifiable by their cones and domes, and probably I would think that 90% of the speakers you look at have these cones and domes, and it is quite common in most studios to have speakers that operate as dynamic drivers. So it comes down to basically a combination of different size dynamic drivers, low frequency woofer cones, and then higher frequency tweeters. The idea these high frequency tweeters or compression drivers can basically move the diaphragm back and forth much faster, and in doing so they can reproduce much higher frequencies than could a 6 or 8 inch subwoofer, which has a lot more mass to move back and forth, and is primarily focused on the lower frequencies and wavelengths of say 50 hertz more than 19K. Check it out. I put a video on the D2L. It's better if you watch it from the D2L than here within this. It's like watching a video within a video. It's lecture inception, and the sound quality is just awful. So please check out the D2L video I put up there right after this lecture. Basically, the advantages of dynamic drivers, they have a wide dynamic range, they can handle very high power, are relatively highly sensitive, have a very simple design, and part of that simple design leads them to be quite rugged within reason. Disadvantages, you often find damaged tweeters. A lot of live sound venues, you end up getting loose voice coils. Driver mount bolts can loosen over time because there is a very physical element to them, just like a dynamic mic. I compare them a lot to a dynamic mic, how rugged they can be, and at the same time, how how they kind of have the same sort of pitfalls of things loosening or damage. Harley goes into a great deal of depth talking about how to understand what the sensitivity of speakers are and what a good sensitivity is. Here I've kind of summated that a high-end speakers often vary between 180 dB per 1 watt per meter to 160 dB per watt per meter. So somewhere within that range. We won't go too far into this, but if you would like to take a look at that chapter, it's under the heading of sensitivity, and it gets into how you can actually evaluate sort of the sensitivity watt per meter, and basically, just to kind of sum it up here, I've put an 80 dB 1 watt per meter per 1 meter will reproduce an SPL or a sound pressure level of 180 dB when driven by 1 watt at 1 meter distance. So that kind of tells you, sort of the sensitivity or sort of, the sensitivity of that particular speaker at a very fixed distance. This is a spec that you'll often see, and like I said, check out the Harley more as he kind of goes a little bit more in depth about how you can use this when choosing speakers. Obviously, all speakers also have electrical resistance, known as impedance. The lower the loudspeaker's impedance, the more demand is placed on the power amplifier. I have fantastic live sound stories about not having the right impedance or creating too much resistance in a circuit and the power amplifier no longer being able to drive the speakers. If you're really interested in this, I would write down the words serial and parallel, and how a parallel amp system in a live sound setup can really help you go from only being able to have 2-stage monitors to 4-stage monitors. Of course, that's a story for another time, but it's important to understand that speakers do have electrical resistance. So how do we choose these loudspeakers? Well, do the reading, right? There's people who read, and then there's those who don't, right? So the world has tons of bad speakers. So use reputable trade magazines for reviews. Make a short list of the best. EQ tends to be a little bit more consumer. Mix tends to have some great articles. I really enjoy Sound on Sound. There's Pro Audio. There's several others. There's also your professors, or engineers that and like their work and can ask them for advice. Things that you should factor are obviously size, appearance, integration, matching the sensitivity and the impedance that we talked about earlier. And use. What are you trying to reproduce? Are you creating hip-hop music or doing sound for film that requires a very, very sensitive look at extreme lows? Or are you dealing with punk rock? What type of loudspeakers are going to meet your needs? Often, other considerations are buy from specialty audio retailers. This could be as special or as unspecial as Sweetwater, all the way up to, as I've mentioned several times now, Vintage Kings, which is sort of a local Nashville place. And buy from companies who make loudspeakers. That is their focus. M Audio has a line of audio speakers, but M Audio, that's not their bread and butter. So Avoid technical claims, and often simple construction and average size is best when choosing your loudspeakers. Auditioning your loudspeakers, what to listen for, and this is great. So we've already told you about 9 times now to go down to Best Buy or to go to Guitar Center or go to Vintage Audio Kings and do a listening test. And we've done it for preamplifiers, we've done it for our source components, in just deciding our high-end audio system. But for speakers, Hartley gives us sort of some very specific advice about what we should be looking for. So, what to listen for? Bass should be quick and clear. I have a pair of speakers at home that are just, these consumer-grade speakers, and I have them hooked up to my TV that just kind of give me a little more low-end when I'm watching Netflix, below, 1080p or even 1080i at that point. And one of the things I notice about them is things that happen in the low end sort of kind of hang out a little bit longer. They're a little bit not muddy, but just sort of, they don't, the bass is not very quick or very clear. You should also think about mid-range coloration. Obviously, as you know, mid-range is very, very important for our mixes. And earlier in the semester, when we talked about spectral balance and how important that, when we did the 250 to 5K test, looking at that mid-range, how important that range be clear and free of coloration. Poor treble. Once again, those home speakers that I have at home, they are very deficient when it comes to highs. They're just initial volume level and how they deal with volume changes, by turning the volume up, turning it down. At different volume levels, do you start to get different mid-range coloration? Does the bass stop being as quick and clear? And then finally, transparency. If you know the recording, and you've got to be listening to either your reference mix or a recording you know well, is that the recording? Are you hearing the recording, or are you hearing a very different story? Are you hearing one that sounds much brighter, much darker than you're used to hearing it? I guess if you don't have a good system or a critical listening environment to base that decision off of, you may just be hearing it the right way for the first time. So please, do be careful that you're not just basing this, well, in earbuds, it sounds like this. One of the great ways to do this is sort of sneak into Lab A and Lab B and test it out. Or even in D&E, the phantom focus systems are great to kind of give you an idea of how this is going to sound. Do be careful. I often find the Genelecs tend to be a little brighter than most speakers.